I'm going to briefly explain what the trapezoidal rule is. So this is chapter 4 or section 4.6. And this is after we've talked about summations of the upper and lower bound. And so before the trapezoidal rule, we were dealing with, let's say we have a curve like this. We were dealing with a bunch of rectangles, and we wanted to add up all the rectangles in order to find or approximate the area. So if we took all these rectangles and we added them up, it would be close. So let's do this. Area of all rectangles is approximately the area under the curve. Right? Because if we color all this in, we see that the only spots we're missing are right in here, these tiny little triangles. And so if, like we were just saying, adding up all these rectangles is going to be close to the area under the curve. What the trapezoidal rule does is it takes the same idea, it gets us even closer to the actual area. So instead of rectangles, we're going to use trapezoids. So as you can see, if we add up area of all trapezoids is still approximately the area under the curve, but this time we are closer. Right? Because if we add up all of these, the only thing we're missing is this tiny sliver right here, right here, right here, right there, all the way up. So with the trapezoidal rule, we are just barely off. And so the way we get the trapezoidal rule is if you look at your book, they have the example here, and they say the area of the first trapezoid is the function of x naught, so that's going to be this point here, plus the function of x1 is going to be this point here, all divided by 2, and then times b minus a over n. So n is, or b minus a over n is this width down here, right? Function x naught is this length here. Function of x1 is this length here. And so if you flip all the way to the beginning of your book and look at trapezoids, look at this trapezoid is almost exactly like that trapezoid. So the area of this trapezoid is h, so the base divided by 2. So if you look here, we have b minus a, so b is this point here, a is this point here, so b minus a gives us this length. We're dividing by n to get that length. And then we have a plus b, so fx naught plus fx1 divided by 2. So instead of, they have the divided by 2 under the sides. So really, the area of a trapezoid is going to be 1/2 times h times a plus b for something like a h and b. And so we're just substituting a equals f of x naught, b equals f of x1, and h equals b minus a divided by n. And so if we plug that back in over here, we're going to get times b minus a over n, and times f x naught plus f x1. So to simplify this, we will get f x naught plus f x1 divided by 2 times b minus a over n, which, I lost my spot. But that is the area of the first trapezoid that we see. It's 4.6. So yes, this is the same thing as this down here. So I'm going to bracket or box this off. And so this is the area for this first trapezoid, right? The area of our next trapezoid is going to be fx1 plus fx2. So this is x naught here, x1, x2, so on and so forth, divided by 2 times b minus a over n. Because the base down here is going to be the same for all of these, right? So this is going to stay the same for all of them. The only thing that's changing is that we're doing f of x1 and f of x2 instead of f of x naught and f of x1. And so this is the area of our second trapezoid. This is the area of our first trapezoid. And so in order to find the area of all of this, we're going to add the first trapezoidal area, the second, the third, the fourth, the fifth, the sixth. We're going to add all of these together just like we did with our rectangles here. And so the way we can do that, the only thing that's changing in this, so we have b minus a over n is never changing because the base is always the same. And we are always dividing by 2. So the only thing that's changing is f of x n minus 1 and plus f of x n, something like that. And so that's where we get the trapezoidal rule on page 336, this one right here. That's where we get that from, right? They just moved the 2 over here, so if we get rid of this, move the 2 here, you're just adding. And so the next one, here, I'll just write it down here, b minus a divided by 2n. You're going to end up with f of x n minus 1 plus f of x n plus, and then you go to the next one. I'll put this in parentheses like this. F of x n plus f of x n plus 1. And then the next one is going to be plus f of x n plus 1. So that's where we see this 2 coming from. Because right here you have 2 f x n. Right here you have 2 f x n plus 1. So that's where we get this equation from. All we have to do is find our n, our b, and our a, and then all these fx, fx plus 1, fx naught, fx1, fx2, and plug it into this equation. So you can see in this example here, right, you have n is 4, b minus a is just going to be pi over 4, so pi over 4 divided by 2n, sorry, this is, yeah. Pi over 4 divided by 2 times 4 would be, I'm going to write it down here. Divided by 2 times 4, which is 8. So we're going to end up with this being 2 pi, which doesn't really make sense. Oh, I'm looking at the... Ah, that's what I did. So if we're looking at example 1, box out. Example 1, we have n equals 4 and delta x equals pi over 4. In other words, b minus a over 2 equals pi over 4. So what we're going to do here is we're going to have pi over 4 sorry, this is just b minus a, not divided by 2, times 1/2 times 4. Still should not be. And I'm not really sure where they got pi over 8. Wait. Well, they have pi over 2 times n, which in this case is 4, which gives us pi over 8. And then from there, you just do pi over 8. Sine x naught is 0, so we put a 0 in there. Then we're doing 2 sine of x1, which is pi over 4. We're doing 2 because, again, you're going to repeat f of x1 twice. And then 2 sine of pi over 2, so on and so forth. And then you just compute this, which should give you pi over 8, 0 plus square root of 2, because it's square root of 2 over 2, and then you're multiplying by 2, so just square root of 2, plus 2, plus square root of 2, so on and so forth. And then this should equal 1.896. So that's my explanation of the trapezoidal rule. Still a little confused on how they got pi over 8. Delta x is b. Oh. I did divided by 2. This should be b minus a over n, which in this case is 4. So then you're multiplying by 2. So this is pi over n times 1/2. That's how we got